I'm going to do the first speech, oil abiotic. May I please court, Your Honor? I, Alnacha Moctezuma, and my partner, Joaquin Cruz, will represent the petitioner, the people in this case. Today, the question in front of this court is a very simple one. Is oil a finite resource? I will speak on the first point of error. How is oil created? This is the fundamental aspect of this entire case. We will prove what oil actually is, how it's created, and what is happening in oil markets today. To do so, we pose a question. Why does everyone seem to believe in the Herbst peak oil theory? Why does the public believe in this theory? Within our arguments, I present convincing evidence that the peak oil theory is based on false premises, that oil is a finite resource, and I will show how oil is actually created. Sir Fred Hoyle in 1982 commented, the suggestion that petroleum might have arisen from some transformation of squat fish or biological detritus is surely the slightest notion to have been entrenched by a substantial number of people over an extended period of time. Sir Fred Hoyle, FRS 1982. Charles E. Melton and A. Gardini explained the general concept of petroleum formation by a biogenic mechanism has been firmly entrenched for a long time, but there has been no accumulation of convincing evidence in support of this belief. Currently, the publicly held theory is that oil and gas are both driven throughout the nature and lengthy decomposition of organic detritus. Therefore, people would naturally believe that oil is a finite resource and that it would eventually run out. In this courtroom today, we will show you that oil and gas are both continuously formed or replaced from a purely physical and chemical thermodynamic process that continuously regenerates oil from ultra-deep locations, 19,000 meters. Then the inference here is that oil may perhaps not be a finite resource and that there is plenty of it. First, oil and gas originates biogenic or abiotic. Do oil and gas originate from biological decomposition of organic materials, or do they originate simply the natural physical and chemical dynamic process involving just heat and pressure? It is notable that the whole Herbst theory of peak oil is rests completely on the assumption that oil is biogenic in origin. Therefore, oil is a finite resource. Simply, everyone believes this because everyone believes that this is a proven fact. I have also read that the biogenic theory directly contradicts and offends the second law of thermodynamics. Evidence for the Western biogenic theory of oil formation. First, in 1757, Russian scholar Mikhail Lomonosov put forward a hypothesis and suggested that oil came from biological detritus. This was based upon the theory was first introduced by George Agricola in 1556. George based his work on Greek Aristotle's work. In 1757, applying a little more observation and limited analyzed tool available in his time, Russian scholar Mikhail Lomonosov is generally considered to have farthered the theory that crude oil, after all percolating a great duration of time, might originate from a biological material. The notion that oil is a fossil fuel was first proposed by Russian scholar Mikhail Lomonosov in 1757. Lomonosov's rudimentary hypothesis based on a limited base of scientific knowledge that existed at the time, and on his simple observation was that rock oil originates as tiny bodies of animal buried in sediment which, under the influence of increased temperature and pressure acting during an unimaginable long period of time, transform into rock and oil. 2.5 centuries later, Lomonosov's theory remains as it was in 1757, an unimproved and almost speculative hypothesis. Returning once again to the Wall Street Journal, we find that although the world has been drilling for oil for generations, little is known about the nature of the resource and underground activities that led to its creation. In spite of the great amount of scientific research, there remains many unresolved questions regarding its origin. Does that not seem a little bit odd what we're talking here? After all, a resource that by all accounts plays a critical role in the vast area of human endeavors. By one published account, petroleum is a raw ingredient in some of 70,000 manufactured products, including medicines, synthetic fabrics, fertilizer, paints, varnish, acrylic, plastics, and cosmetics. By many accounts, the very survival of the human race is entirely dependent on the ability of petroleum. And yet we know almost nothing about this most life substance of Earth's resource. And even though, by central accounts, the well is about to run dry, no one seems overly concerned with understanding the nature and origins of the so-called fossil fuels. We are. content that continuing with the embrace of the unapproval of 18th century theory that is subjected to any sort of logical analysis seems ludicrous. As anyone who stayed awake during high school class knows, oil came from dinosaurs. I remember as a student, my teacher go over and over on the fact that we were running out of it. It seems a reasonable idea at the time from a perspective of a 16-year-old, but as an adult, you really stop to give it some thought. Doesn't that, what's the word I'm looking for? Oh yeah, I remember. Preposterous. How could dinosaurs have possibly created the planet's vast oil fields? Did millions or even billions of them die at the very same time in the very same place? Would the dinosaur Jonestown at the grand scale occurring in a location all across the planet? And how did they get all buried so quickly? Because if they weren't buried right away, wouldn't they just have decomposed or be consumed by scavengers? And how much oil can you really squeeze from a bunch of dead dinosaur skeletons? How many dead dinosaurs does it take to make a barrel of oil? How many barrels of oil have we used so far? If dinosaurs cause the oil, or more correctly, their dead bodies decaying cause the oil, then shouldn't it be a simple formula to figure out how many dinosaurs it took to make oil? Isn't this science in reverse? If oil were a fossil fuel, could you not figure out that one simple fact? Also, wouldn't that make all oil the same age? Wait, if all oil were the same age, that would mean that dinosaurs that made oil all die at the same time, correct? Maybe there was some type of catalyst event that caused a sudden extinction, or dinosaurs all buried them, like the impact of an asteroid or a comet. But even so, you wouldn't think that all dinosaurs would have been just huddled up together, waiting to become oil fields. And besides, scientists are now backing away from the mass extinction theory. Does this mean that without a mass extinction theory, we cannot have oil as a fossil fuel? Does it also mean that oil we have today in one oil field was all made at one time? That all oil had to come from some sort of sudden extinction? Then if dinosaurs lived for millions of years before, what did their dead bodies produce? Therefore, it would take a pretty big pile of dead dinosaurs of count of estimate of 660 billion barrels of oil in the Middle East. I don't know what the percentage of the dinosaur carcass to barrel of oil conversation rate is, but it does seem a lot of dinosaurs. Even if we generally allow one single dinosaur could yield 5 barrels of oil, an assumption, but let's play along. More than 130 billion dinosaurs would have been stimulated entombed in just one small region at the world. But were there really hundreds of billions of dinosaurs roaming the earth? If so, one wonders why we have all these talks about overpopulation and scarce resource, when all we are currently dealing with is a few billion humans populating the same earth. Could the earth have 130 billion dinosaurs in one place like in the Middle East? Now, you would have to also multiply that with the United States, Mexico, Venezuela, Russia, and all the other oil producing areas of the world. Quickly, you will see that we would have over 1 trillion dinosaurs on the earth all dying at one time. We have found some fossil fuels. Have we found them in that type of scale? The answer is resounding no. And why the Middle East? Was that some kind of mecca for the dinosaurs? Was it the climate or the lack of water and vegetation that drew them there? Of course, the region could have been much different in prehistoric times. Maybe it was like the Great Valle in the Land Before Time movies, or maybe the dinosaurs had to cross the Middle East to get to the Great Valley, but they never made it because they just budged down in the desert and ultimately became cans of 10W motor oil. Another version of the fossil fuel story holds that microscopic animals' carcass and other biological matter gathered on the world's seafloor, with the organic matter then being covered over with sediment over the course of million years. You would think, however, that any biological matter would decompose long before being covered over by sediment, but I guess not. And I guess that there was no bottom feeders in those days to clear the ocean floors of organic detritus. Fair enough, but I still don't understand how those massive piles of biological detritus, some consistent of hundreds and billions for tons of matter, could just suddenly appear so that they can just sit there undisturbed and millions of years as they were covered over with sediment. I can't understand how biological detritus could accumulate over time. But I can't understand how biological detritus can accumulate over time mixed with sediment, but there wasn't really created the conditions of a generation of vast reservoirs of crude oil. So I guess I might be missing something here. makes some sense, correct? Have we found most cases the place have produced oil in the past, West Texas and Middle East, for example, were all seabeds. So maybe this theory is correct. It wasn't the dinosaurs entirely. It was the plants and animals in the ocean that died at once. This makes perfect sense until you apply these questions. Did all the plants and animals in the ocean die at once? How can you have oil created from the surface of the earth downwards and have oil at the top the same age as the bottom? Simply you can't. Because according to their own theory, the oil had to be made all at once. For example, let's look at a cook preparing a large kettle of homemade soup. He puts the stock in the kettle, heats the kettle slowly, and then adds different parts of the ingredients. As the soup is cooking, he continues to add ingredients. He adds ingredients until the exact same time the soup is served. Would all the ingredients be cooked? Would all the ingredients be done? The answer is, of course, not. I realize that this is a soup and not oil, but the analogy is very much the same. You must question the fact that biologically speaking, for oil to be biotic, it would have a single source or cause and would have cooked from the bottom up, not the top down. This means clearly that if oil is a fossil fuel, fossils have to be found at the base of the deposits of oil. That means fossils be found levels deeper than oil is being currently pumped at. Today, Russia has many oil wells that are over 30,000 feet deep, yet the deepest fossil fuel has been found is 16,000 feet below the surface of the earth. In conclusion, let's compare the two theories, how oil was created and see which one makes more sense. In Lomonosov theory of 1757, you either have trillions of dinosaurs dying at the same time, plants and animals in the ocean dying. After they die, they all decay at the same time and create oil. Cross-apply these facts. First, for oil to be a fossil fuel, we would have to be overpopulated with dinosaurs. Second, they all have to die at the same time. Third, oil on top of the oil field would have to be newer than oil at the bottom of the field. Fourth, fossils would have to be found at the bottom of all areas that had been drilled. The interesting fact is that none of this happened. Bones of dinosaurs have not been found in numbers sufficient to justify point 1. No scientific evidence has been shown to cause point 2. Number 2, the age of oil field doesn't differ, and fossils have been found only to 16,000 feet, even though we're producing wells that have been dug twice as deep. Wherever the abiotic petroleum hypothesis first gained significant exposure outside the Soviet Union during the 1977 gasoline crisis, when Cornell astrophysics Thomas Gould published an editorial of Wall Street Journal in which he claimed that most deep hydrocarbons are generated abiotically in the mantle and migrate to the crust, where they act as an energy source for microbes producing a deep microbial ecosystem, the deep hot biosphere. That may rifle the surface biosphere in the mass and volume. The organic remains of microbes in the deep hot biosphere represents the source of biological molecules in petroleum as a biological overprint onto an abiotic organic mixture. The proposal contains an implicit concession that biological molecules in petroleum cannot be generated by polymerization of methane. Echoing some of the previous arguments of the Russian-Ukrainian school, Gould presents several lines of evidence for abiotic petroleum, including, first, the presence of clearly abiotic hydrocarbons and other organic molecules in meteorites and other solar system bodies. Second, plausible systematic pathways for mantle hydrocarbon production. Third, the association of hydrocarbon deposits with helium and other trace gases, presumably a mantle source. Fourth, the extends deep microbial communities that impart and overprint biomatters onto the abiotic petroleum. Fifth, the tendency of hydrocarbons reservoirs to occur in many depths in a single locally, implying an underlying deep source. Sixth, the distribution of hydrocarbon deposits related to underlying mantle structure. 7, the destruction of metals and other trace elements in petroleum, which correlate more strongly with conjugate compositions than presumed crystal source. And 8, the occurrence of hydrocarbons in a non-sedimentary formation such as crystalline rock. Clearly, looking at both of the abiotic and biotic theories of the creation of oil, we can see which one is scientific and which one is not based on facts. If there are no further questions, I will retire and I allow my partner, Joaquin Cruz, to stand and present the second point of error. We pray that you vote for the petitioner in this case.
Okay, tell him that your partner will be right there.
Oh. He's gonna go?
Go ahead.
Oh. My partner will be in just a second to present the second point of error.
May it please the court, your honors, I, Joaquin Cruz, will now speak on the second point of error. If we know that oil is not biotic in composition and it is therefore not finite, why are we still believing in the biotic formation of oil? Please cross-apply all of my partner's points and allow me to begin. The history of petroleum science had begun in 1757 when the Russian person of natural gifts, M. Levanso, suggested the hypothesis that oil might originate from biological detritus. During the end of the 19th century, famous Russian chemist Dmitry Mendeleev stated clearly that oil is a primordial native material from great depth mantle. The modern Russian-Ukrainian theory of deep abiotic petroleum origins is not new or recent. The theory was first enunciated by Professor Nikolai Kudryavtsev in 1951, almost half a century ago, and has undergone extensive development, refinement, and application since its introduction. There have been more than 4,000 articles published in the Soviet scientific journals and many books dealing with the modern theory. The writer is presently co-authoring a book upon the subject of the development and applications of the modern theory of petroleum, for which the bibliography requires more than 30 pages. The modern Russian-Ukrainian theory of deep abiotic petroleum origins is not the work of any one single man, nor a few men. The modern theory was developed by hundreds of scientists in the now former USSR, including many of the finest geologists, geochemists, geophysicists, and thermodynamics of that country. There have now been more than 2 generations of geologists, geophysicists, chemists, and other scientists in the USSR who have worked upon and contributed to the development of the modern theory. The modern Russian-Ukrainian theory of deep abiotic petroleum origins is not untested or speculative. On the contrary, the modern theory was first challenged by many traditional-minded geologists at the time of its introduction and during the first decade thereafter. The modern theory was thoroughly examined, extensively reviewed, powerfully debated, and rigorously tested. Every year following 1951, there were important scientific conferences organized in the USSR to debate and evaluate the modern theory, its development, and its predictions. The All-Union Conferences in Petroleum and Petroleum Geology in years 1952 to 1965 dealt particularly with this subject, during which the biotic theory never underwent such extensive challenge or testing. The modern Russian-Ukrainian theory of deep abiotic petroleum origins is not a vague qualitative hypothesis, but stands as a rigorous analytical theory with the mainstream of the modern physical sciences. In this respect, the modern theory differs fundamentally not only from previous hypotheses of a biological origin of petroleum, but also from all traditional geological hypotheses. Since the 19th century, knowledgeable physicists, chemists, thermodynamicists, and chemical engineers have regarded with grave reservations, if not outright disdain, the suggestion that highly reduced hydrocarbon molecules of high free enthalpy might somehow evolve spontaneously from highly oxidized biogenic molecules of low free enthalpy. Beginning in 1964, Soviet scientists carried out extensive theoretical statistical thermodynamic analysis, which established explicitly that the hypothesis of evolution of hydrocarbon molecules from biogenic ones in the temperature and pressure regime of the Earth's near surface crust was glaringly in violation of second law of thermodynamics. They also determined that the evolution of reduced hydrocarbon molecules requires pressures of magnitudes encountered at depths equal to such of the mantle of the Earth. During the second phase of its development, the modern theory of petroleum was entirely recast from a qualitative argument based upon a synthesis of many qualitative facts into a quantitative argument based upon the analytical arguments of quantum statistical mechanics and thermodynamic stability theory. with the transformation of modern theory from a synthetic geology theory, arguing by persuasion, into an analytical physical theory, arguing by compulsion, petroleum geology entered the mainstream of modern science. The modern Russian-Ukrainian theory of deep abiotic petroleum ordnance is not controversial nor presently a matter of academic debate. The period of debate about this extensive body of knowledge has been over for approximately 2 decades. The modern theory is presently applied extensively throughout the former USSR as the guiding perspective for petroleum exploration and development projects. There are presently more than 80 oil and gas fields in the Caspian district alone, which were explored and developed by applying the perspective of the modern theory, and which from the crystalline basement rock. Similarly, such exploration in the Western Siberian Craton sedimentary basin has developed 90 petroleum fields, of which 80 produce either partly or entirely from crystalline basement. The exploration and discoveries of the 11 major and 1 giant fields of the northern flank of the Dnieper basin have already been noted. There are presently deep drilling exploration projects underway in Azur, Tatarstan, and Asian Siberia, directed to testing potential oil and gas reservoirs in the crystalline basement. It appears that, unbeknownst to Westerners, there have actually been for quite some time now 2 competing theories concerning the origins of petroleum. One theory claims that oil is an organic fossil fuel deposited in finite quantities near the planet's surfaces. The other theory claims that oil is continuously generated by natural processes in the Earth's magma. One theory is backed by a massive body of research representing 50 years of extensive scientific inquiry, and the other theory is an unproven relic of the 18th century. One theory anticipates deep oil reserves, refillable oil fields, migratory oil systems, deep sources of generation, and the spontaneous venting of gas and oil. The other theory has a difficult time explaining any such documented phenomenon. So which theory have we in the West, in our infinite wisdom, chosen to embrace? Why the fundamentally absurd fossil fuel theory, of course. The same theory that peak oil doomsday warnings are based on. I'm sorry to report here, by the way, that in doing my homework, I never did come across any of that hard science documenting peak oil that Mr. Straw referred to. All peak oil literature that I found on Rupert's site and elsewhere took for granted that petroleum is a non-renewable fossil fuel. That theory is never questioned, nor in any effort made to validate it. It is simply taken to be an established scientific fact, which it quite obviously is not. First, look at the abiotic hydrocarbons in space. Carbon is the 4th most abundant element in the cosmos, and remote observations indicate that the universe is replete with organic compounds produced without the influence of biology. Studies of the absorption spectra of dense molecular clouds reveal more than 150 small molecules. The greatest amounts of hydrocarbons in our solar system are associated with gas, giant planets, and their satellites, where significant amounts are present in the atmosphere and on icy surfaces. The prevalence of non-biological hydrocarbons in the early stages of our solar system is evidenced by the chemistry of carbonaceous meteorites, which represent fragments of ancient asteroids unchanged since shortly after the birth of the solar system. Carbonaceous meteorites contain percentage levels of organic matter that were generated in the absence of biology. The widespread presence of organic matter in the cosmos suggests that no exotic mechanism therefore need to be invoked to propose abiogenic hydrocarbons on Earth. In fact, the biogenic origin of some hydrocarbons on Earth is thus far a unique observation in an abiotic hydrocarbon-rich universe. In contrast to our cosmic environment, organic matter on Earth is associated primarily with biological processes. The distinction between biological and non-biological organic matter has held a long-term fascination for scientists and philosophers. For instance, all ancient mythologists invoke divine intervention and the use of some abstract vital force for the production of the organic compounds that constitute life. Following the 7th and 6th century BC, such vitalist theories were often challenged by more materialistic concepts that assumed only differences in levels of organization between living and non-living entities. A key moment for materialism came in 1828 when Frederick Worrell produced the organic chemical urea from inorganic ammonium cyanide using a procedure now called the oil synthesis. The generation of organic compound from inorganic material reflects the ability of non-biological processes to produce organic materials, and it is unavoidable conclusion that the origin of life on Earth was by definition a process of abiogenic organic synthesis. In general, organic compounds generated by the abiotic reactions, such as those that produce meteoritic organic matter, are characterized by complete structural diversity. Biological organic compounds produced by synthetic reactions directed by enzymes are notably scientific in structure. Organic compounds in petroleum, by contrast, contain numerous structures in abundances that could not be produced by the random polymerization from methane. Second, experimental hydrocarbon synthesis. Hydrocarbon synthesis is achievable under laboratory conditions and in shallow geological environments, and several key reactions are notable. First, the Fischer-Tropsch synthesis involves the conversion of carbon monoxide or carbon dioxide to hydrocarbons. Second, simple thermal metaphorism of carbonates such as calcite, dolomite, and siderite at 400 degrees Celsius in the presence of H2 can produce a low molecular weight hydrocarbons, as in the following unbalanced reaction. Third, thermal metaphorism of carbonates and graphite below 300 to 400 Celsius may generate methane, as displayed. Fourth, methane is common at mid-ocean ridges, and serpentinization reactions are implicated. Hydrogen forms during the hydration of oblivion and can combine with carbon monoxide to form methane. In addition to those reactions that proceed under conditions relevant to the Earth's near surface, the influence of pressure may be an important factor for synthesis. The environmental control is especially pertinent to the theories of deep gas, and the number of experimental studies as elevated temperatures and pressures relevant to deep crust and mantle conditions point to the possibility of deep abiotic hydrocarbon synthesis. Third, hydrocarbons and minerals. Evidence has been presented for organic proto-molecule assembly in igneous rocks. According to Freud's hypothesis, igneous melts inevitably incorporate carbon and other impurities at high temperatures. As minerals crystallize, they also incorporate a small amount of carbon, which concentrates along linear crystal defects and form alkanes. However, these results have been challenged by other workers. Fourth, abiotic hydrocarbons form hydrothermal vents. A number of authors have presented high experimental, theoretical, and field evidence for the possible release of abiotic hydrocarbon species from hydrothermal vents. Hydrocarbons have been collected from numerous field studies. Observations of gas chemistry, abundance, and fluxes in various vent settings have provided an opportunity to assess quantitatively the relevance of proposed abiotic species to commercial oil and gas resources. These field observations of hydrocarbons from hydrothermal systems have been complemented by experimental studies that attempt to replicate natural conditions. A number of these experiments have demonstrated abiotic formation of methane and other organic compounds, particularly in studies that mimic serpentinization. The experiments underscore the importance of transition elements in the hydrothermal process of organic molecules by Fischer-Tropsch reactions. Cross-apply the main argument put forward by the Western biotic oil theorists in the biomarkers are always found to exist at organic detritus with all oil deposits, which is certainly true. But unfortunately, oil exists inside the Earth, and it is surrounded by different types of geological soils, which all contain organic detritus. And oil is a wonderful solvent in which to dissolve and hold this detritus. Also, and by the reverse argument, alkanes, kerogens, and many other petroleum-related chemicals have been found on meteorites, which can support no organic life. Cross-apply the fact that no fossils have been found below 16,000 feet, yet oil is currently being drilled for up to 40,000 feet. You are left with a controversy. Why are we not told the truth? 7 reasons why we are not told the truth about the sources of oil. First, in the paper of the Abiotic controversy, Richard Heinberg, which sides with the biotic oil, states there is no way to conclusively prove that no petroleum is of abiotic origin. Perhaps one day there will be general agreement that at least some oil is indeed abiotic. Maybe there are indeed deep methane belts 20 miles below the Earth's surface, but the important question to keep in mind is, what are the practical consequences of this discussion now for the problem of global oil depletion? Cross-apply the facts that can't be proven. Cross-apply some maybes. Although by doing this, the biotic oil theorists are really tearing down their own theory. Cross-apply that really the problem here for biotic oil theorists is not how oil is created, but that it is running out. This is a logical fallacy creating a false dilemma. How can you run out of a product that is unlimited? Second, American geologist King M. Hubbard predicted in 1956 that peak oil for the U.S. will peak in 1970. However, in December of 2014, the United States once again leads the world in the production of oil. Third, cross-apply the fact that the laws of thermodynamics prohibit spontaneous evolution of liquid hydrocarbons in the regime of temperature and pressure characteristic of the crust of the Earth. One should not expect there to exist legitimate scientific evidence that might suggest that such could occur. Fourth, oil is often called a fossil fuel, the idea being that it comes from formerly living organisms. This may have been plausible back when oil wells were drilled into fossil layers of the Earth crust, but not today. Great quantities of oil are found in deeper wells that are found below the level of any fossils. Fifth, the Academy of Sciences, Moscow, for almost a century, various predictions have been made that the human race is imminently going to run out of the oil petroleum. The passing time has proven all those predictions to have been utterly wrong. Sixth, one of the most success stories of the practical application of the theory of the abyssal abiogenic origin of petroleum and the exploration in Dnipro Basin, Ukraine, is a cratonic rift basin running in northwest-southeast direction between its northern and southern borders traced, respectively, in the deep Dnipro Basin, northern monocle flank. The sedimentary sequence does not contain any salt-bearing beds, salt domes, nor stratovolcanoes, and no source rocks. Although this flank is characterized by the dense network of the numerous synthetic and antithetic faults, these faults create the mosaic fault block structure of crystalline basement and sedentary cover. Consequently, the Dnipro Basin northern flank earlier was qualified as not a prospective for petroleum production due to the absence of any source rock of petroleum and to the presence of any active, highly dynamic Artesian aquifer. However, after a while, the perspectivity of the area was reinterpreted, re-examined in compliance with the theory of the abysmal abiotic origin of petroleum, starting with a detailed analysis of the tectonic history and geological structure. Seventh, a Russian book, Advanced Drilling Solutions, detailing deep and ultra-deep oil drilling technology beyond the Earth's crust and sedimentary layers to depths of over 40,000 feet, and it occurs in quantity and geological domains where oil is relatively rare or absent, such as within fold and thrust belts. In some large basins, as the West Siberian and San Juan basins, at depths below 15,000 feet. It is peculiar that there has been so little Western scientific peer reviews or acknowledgement of research verification concerning the ultra-deep Russian abiotic formation theory. Surely this is suspicious and bears investigating, even if you don't believe the theory, because this would certainly remove the geopolitical effects and problems of current thinking on oil, that it is running out. Concerning this theory, I have shown you why it is wrong. In the end, you would have to agree that Russian abiotic theory of oil formation, backed up by all its evidence, is far more likely to be a true explanation, and there appears to be little or no conclusive evidence to prove the Western biotic theory of oil. But that in and of itself leaves much unanswered questions, doesn't it? For what reasons then, in light of these facts and conclusions, is the peak oil theory formation so heavily regarded? Are Western geologists and scientists really that stupid or unfair, or is there an underlying hidden agenda that the media steerage here by big oil majors or OPEC to perhaps discreetly encourage higher oil prices through promotion of a false scarcity of this resource by conveniently supporting the Western biotic theory of oil formation? The only way to gain from taunting this theory and the oil companies themselves They pushed oil to record heights and held the developed world hostage to their whims. Then in the summer of 2014, a break in the stranglehold they once held on the exporting of oil. This was because of a national greed and the fact that U.S. is now producing more tons of oil. I leave you with the question and a prayer. Could oil actually lose 50% of its value if we were running out of it? And if so, why?
Okay, your turn. Go ahead. Your turn to present if you'd like, please.
What is that? So our turn or your turn, like her turn, we're kind of.
Go ahead.
Oh wait. Okay, then I guess I'll start.
Thanks, man.
First of all, great job on both those presentations.
We can't hear them.
Can you hear us?
Yeah,
Yes.
sure.
Can you hear us?
Okay.
Hello?
Yeah, go ahead. Go ahead.
Yeah, well, my apologies. We're a little bit quiet here, but well, it happens. What can you do? First of all, congratulations to both your reporters. These were some amazing works, I have to say, and you do both make an extremely solid point. Very well made, I must say. We took a little bit of a serious approach here and decided to present our country and its state in renewable fuels. As you've pretty much cleared everything that's, well, about oil, we're going to move to other sources, especially around the country. I'm going to start about our biofuel situation. Our situation is that here in Slovenia, we have cows, farmers, wine, taxes, and trees. Trees apparently cover more than half of the country, and that's pretty much it. There is nothing much to say about us. Well, if you're a hippie, you might find it rather interesting to hug some trees, but that's another story for another day.
Okay, well, biofuel is used to refer to sources of energy that come from nature: wood, hay, waste. They're extracted in ways such as mining, pumping, or in our case, wood cutting. In Slovenia, 53% of wooden biomass is used for heating purposes. And if you look at Europe and its ability to harvest biomass, we come out as one of the top countries that have this potential, as more than half of the country is covered in forests. Also, for the record, we already use some quiet biomass as it is, but we could use more with careful planning, as I will explain further. So the point is that we have a lot of trees, and we could use those trees for energy solutions, as with careful planning and wood cutting, our losses would be neglected. Trees could also be more utilized in the case of production and export. Another thing is that a part of our wood production gets sent abroad, there it is refined and then gets sold back to us. If we would build more of an industry around those things, we could minimize our losses and increase profits. Trees could also be more utilized as biofuels for a population. Due to low transportation costs and the potential of being refined here instead of abroad, thus generating more income and providing growth, it could prove as a cost-effective solution. As a positive result, we could be less dependent on importers, and if the area grows enough, we could even achieve the state of exporting into other countries, thus increasing jobs and general improvement of our economic state.
Another thing which makes biomass such a great solution is the fact that, well, at least most of it, trees in our example, it can regenerate itself. And with careful planning, we could, as my friend here mentioned earlier, simply neglect any losses that advanced wood cutting could bring forth and destroy forests. So we neglect that out. So apparently, when it comes to wood, the Forestry Institute of Slovenia apparently states that we already use a lot of it for heating purposes, not so much for energy purposes and production, which is another thing which we could expand. Although overall biomass is greatly unused because we use only 3% of it to generate energy. So we definitely need to work on that part. Right now, there is a problem that denies on increasing foresting, which is the fact we have extensive loss and the economic crisis, which hit us, well, actually hit our companies a lot more than hit the population. So apparently, many companies had to compensate and downscale for their losses. So expanding forestry is actually not very requested right now. A lot of import is going in from the rest of Europe, and as stated before, they're even rebrushing their own wood. So until we get our economic stuff together, not a lot of pressure is going to be put in this direction. So until those laws and the demand for fuels change, we will be, as stated, a #1 vacation spot for environmentalists and hippies alike, whose tree-hugging techniques will soon make this country into a hippie utopia, filled with trees and nature and stuff, like a modern-day Narnia or something. But biomass doesn't only stand for wood cutting, it refers to all forms of energy that come from the sun or one another. Sources such as solar energy are also present, but apparently underused throughout the world, by my opinion. Although sugar also comes under the biomass category, we don't really use it. And there also have starch, oils, and gases. Although we already use biomass to produce fuel, biodiesel to be exact, which could potentially be a great replacement for oil and other sources of fuels, but we're going to have to expand in this section a lot more. So theoretically, at the state in which we stand right now, we're going to have to expand our economics and increase demand for biofuels and regenerative sources, such as trees, as stated in this edition. This text is definitely not as long as yours, my apologies, but I'm sure that with the time we have left, we'll be able to fill in the gap quite nicely.
Well, hello. Me and my partner are going to talk about solar energy. I believe that we are all familiar with. So, as we all know, solar energy is free. So this is a pro, um, and it does not cause pollution. It can be used in remote areas, and many everyday items such as calculators and other low power consuming devices can be provided by solar energy. And it is also estimated that the world's oil reserves will last for only 30 to 40 years more. So the solar energy will last forever, so we can use it a little bit more. We also have cons about the solar energy, such as solar energy is free, but there is a cost in building collectors and other required equipment to convert solar energy to electricity and hot water. Solar collectors and other associated equipment cause some pollution, and solar energy can only be produced during the day and sunny weather, and it is expensive.
Okay, so those were just some of the basic pros and cons. Now, here in our country, ever since 2010, we've actually installed about 400 new solar plants, but I couldn't find any specific locations. So currently here in Slovenia, there's about 82,000 square meters, and doing the math, that would produce about 29,000 megawatts of energy per year. Our best climate is at our coast, which is somewhere at the southwest, you could say. However, we're actually using the more, how should I put this? More than the most is used currently at the southeast. More than half of the plants are located over there in the country. The most power is used in our second largest capital. We only produce about 20.5 megawatts. That's about a third of all the power from the solar we get here. The reason we have so little, the reason why we use so little solar is basically because it's kind of a small country. It was actually a survey online depicting in Slovenia, so the support it has is pretty positive. There's about 97% of the population that supports this energy, and it's kind of been rising here ever since 2005. Now, the only types we actually use are the panels, and about 97.6% is kind of used here. Also, the most countries that actually do use this are the United Kingdom, Belgium, Australia, France, Spain, the United States, Japan, Italy, China, and Germany. Germany has been using this energy for the most time and is also, it uses it the most, about 35.5 gigawatts per year. Other countries would be Canada and South Africa. I guess that's it.
Hi, I represent you Hydropower. Hydropower is using water to power machinery or make electricity. Water consistently moves through a vast global cycle from lakes and oceans, forming clouds, precipitating as a rain or snow, then flowing back down to the ocean. The energy of this water cycle, which is driven by the sun, can be tapped to produce electricity or for mechanical tasks like greening grain. Yeah. Hydropower uses a fuel water that is not reduced or used up in the process because the water cycle is endless, constantly returning system. Hydropower is considered as a renewable energy. So I try to find answers to my questions about how much energy we get from the rivers and lakes. Because Slovenia has many lakes and rivers, I found out that we provide 21.6% of hydro energy. I will present you pros and cons. Advantages of hydropower are hydropower is fueled by water, so it's a clean fuel source, meaning it won't pollute the air like power plants that burn fossil fuels such as coal or natural gas. Hydroelectric power is a domestic source of energy, allowing each state to produce their own energy without being reliant on international fuel sources. The energy generated through hydropower relies on the water cycle, which is driven by the sun, making it a reliable power source, making it a more reliable and affordable source than fossil fuels that are quickly being depleted. Some hydropower facilities can quickly go from zero power to maximum power because hydropower plants can generate power to the grid immediately. They provide essential backup power during major electricity outages or disruptions. In addition to a responsible fuel source, hydropower efforts produce a number of benefits such as flood control, immigration, and water supply. And disadvantages of hydropower, we have also many disadvantages of hydroelectric power, due to which is not used on a very large scale around the globe. They're like emission of methane and carbon dioxide, disturbance of habitat, installation costs, a limited use, divert natural waterway, effects on agriculture.
Hello, I will present to you wind energy. Slovenia is about 1/4 of the size of Ireland and currently has no wind energy, but already there are strong parallels with our own experience. The future plans of our government is to build a wind factory in our region, in Slovenia. There is a bad national policy as far as the wind energy is considered in Slovenia. There are even no laws encompassing wind turbines, and what is even worse, the Noise Act and all are legalization do not mention turbines. Slovenia has only two wind turbines. The first one is located in Dolenjavac. It produces 2.3 megawatts and its height is 98 meters. From the residents at Dolenjavac near Nožeče, all the okay, we can skip that. Pardon me. The second one produces 0.9 megawatts, and it's located in Divača.
Well, looking at our time, I believe that's all that we can say from our side at the moment.
We had a couple of questions, if it's okay.
Well, sure, of course, for all ears.
So for this first speaker, I'm gonna ask, what is the gasoline price in Slovenia?
All honesty, I don't really know the exact numbers as I don't have a car. Fortunate. But it is true that the prices of wood, which is about my topic, are about 50% lower than the prices of oil throughout Europe. That's all I got. Sorry, I have to work for that.
How much is their energy by renewables?
Well, right now it's fairly underutilized. We have a large amount of rivers, as my friend here mentioned. Also, wind energy is underutilized. So I believe that renewable energy is about 3%. Like I said, it's incredibly low at this moment. So we're hoping for a brighter future, possibly expand in this area, but otherwise it's still going to be, well, rather small, to say the least.
Also, I have another question. How big is it, and how many people are in the area?
How big is Slovenia?
Yeah.
How many people live there?
Slovenia.
Well, it's rather small, as a matter of fact. You probably don't see it when you look at the map. Like my friend said, it's a quarter of Ireland, so it's pretty damn small. At a population like really slightly above 2 million at the moment, but increasing, that's true. Currently, you probably have no idea where we are, which we can't blame you for. I believe it's best if you simply look us up on the map. We're between Italy, Austria, Hungary, and Croatia, like on the right side of Italy, and then you can get yourself a clear image of how small we actually are. We're pretty small.
How long have y'all been learning English? Because y'all English is pretty good.
Well, I'm going to pass the mic around to my friends here. That's okay. I've been learning English. I don't know, my parents say it because they enrolled me in English kindergarten. Otherwise, it's because I discovered video games and Cartoon Network. Great source of education.
Sorry.
It's bad. I say no. That stuff taught me English. I'm sorry. We pass the mic here.
Okay, so I have been learning English for probably about 11 years because it's in primary school. We start learning in grade 4, so we're all pretty good. And of course, movies and yeah, Cartoon Network.
Yeah, I agree. I've also been learning English for about 11 years now from school and movies, books.
I've been learning it for about 14 years now. I just started by watching a bunch of cartoons. I started asking a bunch of people what specific words meant. So I just started formulating a few sentences, and yeah, that's about it. I got lucky and I memorized a few stuff, so that's it.
For 11 years, but I mostly learned English from TV shows and movies.
I'm learning English for about 12 years, and I mostly learned English from Cartoon Network. When I was little, I would always watch cartoons and movies. And okay, at primary school, that where I learned English the right way.
Could you tell us a little bit about Slovenian? What does Slovenian language sound like?
Well, we are in the Slovak language group. We're rather distinctive from Russian, although we're really, really far apart. Not sure if you have heard it.
Okay, so give us a sentence and we're gonna say it.
That works.
Hi, how are you doing?
Bravo, kako ste kaj danes is a prime example. Perfect sentence, nicely formulated and such.
What about hello?
Živjo.
Yeah, Julio, as they said. It's very difficult, I must mention that, from the only languages that include duality in a way. Another, well, way to say words being single and, well, plural form. So yeah, we're pretty damn difficult to say the least. Which means for us. Yeah.
How big is y'all's high school? Real high school?
High school, Kokchansa.
How like big is it?
The building is rather standard. We are expecting a lot of new students coming in or merging with another high school to a new location and stuff like that. Things are changing. Otherwise, I believe that we have around 500 students at the moment. But as I said, we're currently merging, so we're expecting a large increase in the number of students currently in this building. Otherwise, building-wise, it's quite nice, spacious, fine. Yeah. And your guys, how much you guys do that?
How much are Are you asking of our high school?
Yes.
Yeah. Why not?
You want to answer that?
I have no idea. Our
3,000.
It's like 3,000 kids. It's 2-story. Yeah, and we have how many? Like, how big do you think it is?
I don't know, but it's the physical. We've added on about 3 or 4 times. 15 years ago, we had about 1,500 students. Today, we have around 3,000. Of the 3,000 students, the majority of the students will be Hispanic, and the vast majority English will be their second language. So most people will speak Spanish at the house. So we'll have a lot of bilingual people. So it's interesting. But they anticipate that in 2 years we'll have 4,000 students.
That's quite the number.
That's a lot.
To give you an idea, we have about, in the Austin area where we're at, we have about 2 million people live in our Austin metro area. So our metro area would be about as many people that live in Slovenia.
That's a lot. Nothing more to say to it.
Yeah. What do you guys want to do when you get, what are you going to major in college?
College. Ooh, I'm going to pass the mic around here again. I'm planning to continue my reign of economic terror, possibly IT, politics, who knows? Well, that's pretty much it.
Well, the choice is too hard, so I don't really know, but might be something in computing or science or something. I'm gonna see.
Well, I believe that I will study sociology or something like that because I like something.
I'm not even sure if I want to go to college, but if I do, I would probably want to study, I don't know, anything to do with economics, technology, research, something. I don't know.
Probably management.
I'm thinking about studying English or tourism.
What about you?
I'm gonna study law and criminal justice.
I'm gonna study probably the same thing.
I have another question. How much is your like college tuition?
College tuition is an astonishing number of 0.00. It's free. Taxpayers pay for all of it, so what's there to complain? Also, apart from free schooling, there's no scholarships in public schools. We also have a rather friendly medical system. I believe its citizens granted a basic medical for emergencies. So yeah, while we are known to have rather high taxes, it means that I can go to school without spending a dime apart from books, which is a big burden if you ask me, because nobody likes books.
Just to give you an idea here, both these two students will be graduating from high school in a couple of weeks and going to college, and they're looking at probably college costs of about $30,000 a year American. So a lot of people go into debt. It's just fantastic. Now, the people who are in ninth grade, they estimate that they'll be in debt maybe $200,000 by the time they get out of college. So it's making a lot of people some very hard choices.
Well, looks like a good motivation to get a good job, if you ask me.
Yeah, well, the bad part about it is it's kind of generational. I was able to work my way through college by working a job, but today, if you get a job, it's almost counterproductive. You're better off taking extra courses in high school than a job because you get better scholarships, and scholarships take out more than working by the hour. You guys are very lucky to get what you have where you're at. You're very blessed.
Well,
No.
That's all our questions.
Do you have any questions for us at all?
I'm clearing it here. Nope. Looks like we're pretty much fine around here.
What's your weather like there?
Weather, ooh.
It's not sunny.
Right now it's
That's
raining.
Yeah, and it's cloudy.
Although we're getting rather above average temperatures this May, which is, well, we're basically getting baseline summer temperatures, for which I blame global warming.
Yeah, we've had some temperatures here in the States. I think the wind chills are still in the 20-degree Fahrenheit. So, I love when they talk about global warming because they blame it on both sides. We've had a drought for about 4 years, but the last 2 weeks we've had rain. It's really bad. So it's raining here today as well. But we sure do appreciate this, and hopefully we can do it again. When do you guys get out of school? When's your term end?
Sure, man. I believe in a rough month or so. Yeah, but really good. Although seniors, I believe they should be gone by now. This is their last week.
Oh, wow.
What?
Yeah, last week for seniors. Otherwise, we're still stuck here for 1 month.
Oh,
Do all the interesting things in life.
yeah. Well, that's unfortunate. It's just really odd. There's many schools in the United States are already out, and I know Iran's out this week. A lot of schools, it's just like all over the place. You figure it'd be some sort of universal. When do you start in the fall? After Labor Day? I mean, after September 1st?
Yeah, that's pretty much it. Yeah, basically. We do have quite a lot of small vacations in between, like a couple of days here, a couple of days there, and stuff like that. I believe it adds up to the same values at the end of the day, but nevertheless.
And normally, what time do you go to school and what time do you go home?
It depends. Usually class starts at about 7 in the morning. So,
Wow.
some of us actually have to leave about maybe 2 hours earlier. Some at 6. And it's over usually at about 1:15.
Or 2 p.m.
Yeah.
Wow.
Not too bad, actually.
What about you?
3 o'clock.
Our school starts at 8:30 in the morning and it ends at 4 o'clock in the afternoon. And we can't leave unless you have a job or you have you don't have no classes to attend.
Yeah, it's relatively much more regulated, you know, in that. And you go to school Monday through Friday, correct?
Yeah.
Of course, of course.
Yeah, I know in Italy they go on Saturday as well.
That's torture right there.
Oh.
And we're graduating like at June, what is it, 4th?
Yeah.
But we still have to come the next day to school, so kind of weird.
Yeah, they graduate, they have to come back the next day. That's going to be an awesome experience. But we sure do appreciate this experience, and we look forward to doing it again, okay?
Yeah, same
Yeah,
here. It's been a
sorry.
great pleasure, I must say.
Thank you so much.
Thank you.
Bye.
Bye.
Goodbye. We leave the meeting now, stuff like that.
Yep.
I'm gonna click the button. Bye.
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 Yes.